So in this video, I'm going to talk about two-way analysis of variance. I'll try to understand the formula we're going to use to get all this source manually, step by step. So, well, in the source of variation, if I look into that, we have SSA, sum squared A, in this case row factor, we also call it sample, and sum squared B, we call it column factor, and sum square AB is like interaction between column and the rows, and this one SSE sum square error within is the same as 1-way ANOVA, and also SST total is the same as 1-way ANOVA. So these two are basically the old stuff. Now this three is gonna be a little bit new stuff, and of course we have to pay attention. Now I can start with a look into here sum squared. How do you get that? SST is the same as old formula, again same as old and 1-way ANOVA, and SSA is like row factor. So up here I actually put down this is a slightly different formula as 1-way ANOVA. Remember 1-way ANOVA we have only one factor. The 2-way ANOVA we have two factor, multiple factors. So I have to introduce something. Let's look into an example that will help us understand what are these A and B and N and what is this total and N. Let's actually look into this example here. So if we look into this example here and we see this is a factor B and this is a factor A, and this factor B, under the factor B we have a 3 group. So I'm going to actually categorize it. It's very important we understand this one here. So I'm going to put down B here as a 3. Why did I put down 3? Because I have a 3 column. That's my B. Again, that's my level B. So also on the left side, this is my category. Remember, we need a 3 or more to run ANOVA. And up here, if I look into factor A, the factor A has 2 layers, hot and cold. So in this case, I can actually factor A, I can actually label it as A. So A, how many level we have? In this case, 2. So A is also 2. Again, hot and cold, so that's 2. Also, one more thing we're gonna need, we need the N. Remember, notice that there is N, small n also. So what is the N? N is how many rows? So I'm going to put down N is equal to 2 rows. N is equal to 2 rows. Doesn't matter we look into here or look into there. So only one N we're going to use as a 2. Okay. So if we look into this right now in the left side here, so sum of A sub I to the power 2. I could have written actually sum of total square over B times N. It's the same thing actually. If you don't like this notation actually, if we don't like this notation, we can actually, instead of this, we can put down T is the same as 1-way ANOVA, total square minus total square over N. So N is the number of rows and N is total number of sample. Again, number of rows for what? I would like to actually make sure we understand that for each group, I mean each row here with the level. So it's not a total, it's not a 4, it's like 2, 2. So we're just going to use 2. And obviously the next one we have here B. So well, that's why we need up here B as a level, so we know we can plug it in here. So A and B, we can plug it like that and so on. These are the formula. And if we look into here on the bottom, and this is the error, we just actually have to have the total and we just subtract all of them. So this is the formula. Now how we are going to use this formula, let's actually work it out here one by one. Okay, so let's talk about SST, sum of x square minus t square total square over n. So well, total, if we add all of this, I can say sum of x same as total is equal to, is going to give me 25. You just add all of this here, is going to give us 25. Okay, then the next one we need the sum of x square. So how do we get the sum of x square? Sum of x square is equal to, or I can say sum of x square in this case is going to give us, you square all this number, 1 square, 2 square, 2 square, and you add in between. So if we do add in between like that, we are going to get something called total. In this total is going to be 63. we add all of this, is going to give us 63. So then we just plug it in here. So that's 63. This 63 is going to give us, we just plug it in here, and of course this 25, we're going to plug it in here. Okay, so let's take a look what we have. So 63 minus 25 square over n, in this case is 12 again. So we need n is equal to 12. Why n is equal to 12? Because 1 2 3 4 4 times 3 is 12, or just count 1 2 3 and so on. This is going to be 12 of them, so that's 12 down here, up there. So if we plug this in, any calculator is going to give us approximately 10.917. 3 decimal place is fine, approximately that, 10.917. Okay, so let's move into the next one, SSA, which is the simple or row factor. So this one is sum of S. Why I have a double sum? Remember, we have to actually work it out a little bit slightly different way. Okay, so we can actually get the sum of this first row, I mean the hot, and sum of the cold, okay, this row. So we are going to actually add this up here to that. So in the meantime, I'm going to put down total, and also I'm going to add this up. If I add this up, it's going to give me 15. Also, if I add this up, it's going to give me 10, and I'm looking for total sum. So that would give me total, in this case is going to give me 25. So what can we do? We are going to actually use this information to find this up. Remember total, so it's going to be more than 1. So 15 square plus 10 square, remember 15 square plus 10 square, this is going to be slightly different than the last one we have done. So well, let's take a look here. How can we do this one here? So in this case, 15 square plus 10 square, remember double sum here, so 15 square plus 10 square. We have done that for 1 over ANOVA also, but up here in 1 over ANOVA we actually divide by the sample size, but we are not going to do that this time because we have double factor. So we are going to actually look into B. So what is the B here? B in this case is 3. So we say 3 times, what is the N? N is 2. So 3 times 2. That's it. This is how we work it out. Then minus, we already have that here. We already have that. I would like to reiterate here. So this is already, we have it here. So all we can do, we can just substitute. Sorry about that, my apology. We will substitute. So it's going to be 25 square over 12. And if we do the math here a little bit, it's going to give us 2.083. 3 decimal is fine, approximately. This is what? This is the row factor. So we actually work out the row factor. 10.917, and we have SSA 2.083. Okay, now let's move into the column. SSB, in this case, column factor. So same thing, double factor here. So well, it seems like we have 3 columns. So what we are going to do, we're going to actually add this up. So if I add this up, it's going to give me 6. Again, if I add this up, it's going to give me 6, and this one is going to give me 10. Add all this up, and finally if I do add this up, it's going to give me 9. And also I need a total. Well, actually, it's going to give us 25, as before. It's going to be 25. So that's, I don't need to put equal sign here. Okay, that's fine. That's a total sum. If I add this up, it's going to be 25. Okay, so what are we going to do with this actually? So we are going to actually use this. In this case, b is the three of them, so we're just going to add three of them: 6 square plus 10 square plus 9 square. So let's take a look here. Let me do this here. So 6 square plus 10 square plus 9 square over something we have to pay attention here. It's very important here. Over a times n. So a is 2 times n is also 2. So this time 2 times 2. 2 times 2. That's very important. We'll look into this one actually here this time. So minus the subtraction of the total. So minus this total square, the same thing all on the before one. So we're gonna just rewrite it here actually. So 25 square over 12. So if you do this math here, we are gonna get something that is 2.167. Two decimal place is fine. Okay, now we're gonna move into both column and row factor. So again, factor A and factor B, what is happening in between? What is the interaction? So in this formula, we are going to actually work with for both A and B. Then of course we already worked with A and we already worked with B, and all these are already done. So we are just going to substitute here. So well, how do we actually find this one out? So this one is a little bit complicated. We're gonna have to create a little space here in between after them actually. So after that first layer. So what we are going to do, because we are looking into both OS, so in this case we are going to actually look into the summation. We have actually sum of x and sum of x square. So we're going to have a sum of x here. So sum of x is 3 here, and this is 5 here, and this is 7 here. And sum of x square. Sum of x square is going to be 9, and it's going to be 25, is going to be 49. That is going to be 4. Now again, this one is only 2 rows. If number of rows are higher, then it's going to get more complicated actually. It's going to get more complicated. But this is the steps we're going to take actually. So well, what are we going to do here in this case? So we're going to actually have this is like a total square here. So we're just going to add this up here to the right side. That is total. In this case, total is what? ED3. Also, we're going to add this up here on the second layer and the cold one, that is 38. We're also going to look at the total sum. So that is going to give us 121. So we are going to use all this data into this up here. So we can plug this in here this time. SSAB, we look into that actually. So 121 over 2. So this is total 121 over the n. So 121 over n. Again, n is what? N is 2. Why? Because this is 2 row. So that 1 2 row, 1 2 row. So n is 2. So I can even put down n is equal to 2. So 121 over 2 minus, we already worked it out earlier for row factor, and also we did column factor. So we are just going to use that same thing up here. Okay, so we're going to use 15 square plus 10 square. We already had that earlier, over, in this case, 3 by 2. Why 3 by 2? Because b is 3 and n is 2. So that's why we have 3 by 2. 3 times 2 minus, this time is column factor. So column factor is we already worked out earlier. It was 6 square plus 10 square plus 9 square over a times n. So while a is in this case is 2, n is also 2. Again, n is going to be 3 if there is a 3 row. N is going to be 4 if there is 4 rows. So to ANOVA we must have same number of rows. So in this case, up here 2 times 2. So that would be 2 times 2. 2 by 2. Plus, remember, we are looking for interaction. So instead of subtracting, we're going to add this time. What we are going to add? Total square. We're going to add total square over n, 25 square over 12. 25 square over 12. So if we just type this in a calculator, we will most probably get something. And of course, the easy way, if you try to type everything in the calculator, you might get into error message or wrong answer. It's always a wise idea you do this piece by piece. So if I divide this, it's going to give me 60.5 minus. If I work out this piece here, it's going to give me 54.167. Next one is 54.25, and next one is plus 52.08. Finally, if I simplify it, it's going to give me 4.163. And that is what? That is the factor, interaction between them. Okay, so let's move into the error. So error is basically SST total minus this. Actually, if I do that, we can find the error actually. So we're just gonna substitute it here. So SST is gonna come down here, SSA is gonna be down there, and SSB is gonna be down here, and SSAB is gonna be down there. SST is 10.917 minus 2.083 minus 2.167 minus 4.163. And if we do this math, a little math, we're gonna get 2.504 approximately. So we do have our error. So we technically have everything. Now I'm going to plug this in, 2.540, 2.540. Okay, so now we're going to work on degree of freedom. So what is the degree of freedom for group A, in this case, a row factor? So A minus 1, where A is the number of factor of row level. So row level is number of factor of row level is 2. So 2 minus 1 is 1. So 2 minus 1 is 1. Then of course we work on for group B. For group B, so this is a column. So in this case B minus 1. B minus 1 is 3 minus 1, which is equal to 2. And up on the top one is basically 2 minus 1, which is equal to 1. So that would be my degree of freedom is 2. Then of course I'm going to go with the degree of freedom with the interaction. So in this case is A, in this case is A, again A is right here, okay, A is right here, and also B is going to be right here. So all we can do is, which is 2 minus 1 times B is 3 minus 1, so that will give me also 2. In other words, 1 times 2 is 2. So that would be 2. Now then one more stuff here. Degree of freedom for the error n minus A times B. So what is n? N is the total sample. So n is total sample. In this case, total sample is 12. Minus A, which is 2, times B, which is 3. If we do work it out, it's going to be 6, and basically is going to be 6. 12 take away 6 is still 6. So that is degree of freedom is 6. Once you have all these, we just plug it in actually here. Here you go, 6 plus 2 is 8, 8 plus 2 is 10, plus 1 is 11. Whereas we can actually do this way also. N is 12 to equal 1, that would also give 11. So total number of degree of freedom is 11. The next we're going to move into the mean square. Mean square is basically ratio between those two. So mean square, we take the ratio between SS and degree of freedom. It's mean square, we take the ratio between SS over degree of freedom. So if you just plug this in, we should get 2.083, and the next one's supposed to give us 1.083, and the following one should give us 2.083, and the following one should give us 0.417. Okay, now we're going to look for test statistics. So test statistics, what is the rule? We use the test statistics mean square, that is the mean square, divided by the MS error. So divided by the error. So the mean square, this is the mean square, this is the mean square for row, mean square for column, mean square for interaction, and this is the within. Remember, we need a 3F test, 3 statistics. In 2-way ANOVA double factor, we're going to have a 3F statistics, and of course we're going to have a 3 null and alternative hypothesis too. So let's take a look here. 2.083, if I go down here, 2.083 over margin of mean square error is 4.417, and that approximately would give us 5. That would give us 5, and we are going to keep doing the same thing for the rest of them actually. For example, 1.083 over same 0.417, and that is going to give us a 2.6, and we can even go further actually. Further mean we can go next one, which is 2.083 over 0.417, that would approximately be also 5. That would approximately be also 5. So we get a 5 here. Let's put that in. 5 there. 2.6. That's a 5. That is how we actually find the formula and fill out the source and understand the formula. So I hope you understood it, and I think this is the best way or easy way to understand, and that will work for 3 rows, 4 rows, or multiple columns is going to be the same, unless it is not another factor, multi-factor. If it is 2-factor, that is fine actually. We can use this formula, and next video I'm going to explain actually complete hypothesis test for 2-way ANOVA. That will also have the null hypothesis, alternative hypothesis for all 3 options, row, column, and AB, both factors, and also as usual the conclusion.